Hello and welcome to viewers of Sriman Narayan Physics. My dear students, today the video program about which you are going to observe, it is dealt with parallel plate capacitor. प्यारे बच्चों, आज के इस वीडियो प्रोग्राम का जो मकसद है वह पैरेलल प्लेट कैपेसिटर के बारे में जानना है, उसके बारे में सीखना है. So, as previously I have discussed to you, that is in my previous video lecture, already I have described to you people about the principle of capacitor, what is a capacitor and what is its principle. Now, today I am going to discuss to you people about the construction of parallel plate capacitor. We will also learn about the field lines and the formula for calculating the capacity of a parallel plate capacitor. So let us start. A parallel plate capacitor is consisted of two metallic plates X and Y. See here, this is a metallic plate. Let it is marked by X, and suppose on this metallic plate positive charge is given plus q coulomb of charge is supplied. When this plus q coulomb of charge will be given to this metallic plate, this charge will spread out over the entire outer surface of this metallic plate. You can see it is clear from the figure. Now we take another similar identical plate, and suppose this plate is marked by Y. You can see it is identical, it is similar to the plate X. That this plate is marked by Y. Now it is clear that on the inner face of this plate Y, negative charges will be induced, as it is clear from the figure, while on the other face of this plate Y, positive charge will be induced. And suppose this conductor, this plate Y, is allowed to connect with the ground as shown in the figure. When this plate Y is earthly grounded, this wholesome positive charge will be neutralized by the earth. So the only induced charge, it will be this charge minus q. So it is clear, if there is plus q charge on this plate, there will be minus q coulomb of charge. This charge, it is also called the bound charge. Now it is clear that these two metallic plates are equal and opposite charge. Let this arrangement, so called the parallel plate capacitor, it is an ideal parallel plate capacitor. So if it is an ideal parallel plate capacitor, then remember here that the region lying in between these two plates, it will be of uniform electric field. I mean to say that any point lying in between the region of two plates, the value of electric field intensity, it will be same. Now, as the field is uniform, so you can observe the pattern of field lines. You can see the field lines patterns are like this. It is clear from the figure. All the field lines are equidistant, equispaced, straight lined and unidirectional. See here, it is clear from the figure. Now, one thing I would like to discuss to you people, that the field at the end of these two plates, that is in this position, it is very weak and it is negligibly small. A special name is given for the electric field produced near the end points of the plate, and this field is called fringe field. Now the field line patterns at the end points are like this. You can see these are the field line patterns at the end points. You can see here, and these field line patterns are telling that near the end points of these two plates, the field is very weak. Now, the medium in between these two plates, it is air, and in practical life, the separation between these two plates is very small. This assembly is nothing but parallel plate capacitor. Now, I want to calculate the value of capacity for this parallel plate capacitor. So, for this purpose, let the plate area of either of the two plates, plate area of either of the two plates is capital A. Also consider that plate separation, it is equal to D. Plate separation is small d. As the charge is positive, so for this plate, the surface density of charge is plus sigma, and for this plate, the surface density of charge is minus sigma. My dear students, if you will think about the net charge of this system, it will be plus q minus q, that is 0. But remember here, when one asked a question that what is the charge of this capacitor, then always mind, whatever the charge is given to this plate X, it is called the charge of this capacitor. प्यारे बच्चों, अगर तुमसे ये कहा जाए कि इस पैरेलल प्लेट कैपेसिटर का नेट चार्ज कितना हुआ, तो प्लस क्यू माइनस क्यू बराबर 0 हुआ. लेकिन अगर तुमसे कोई ये पूछे कि इस पैरेलल प्लेट कैपेसिटर के लिए चार्ज क्या है भाई, तो तुम ये कहना कि ये जो प्लेट X है, इस प्लेट X पर जितना चार्ज एग्जिस्ट करता है, यानी पॉजिटिव चार्ज एग्जिस्ट करता है, और यहाँ पर हमने प्लस क्यू कूलम का चार्ज दिया है, इसलिए तुम्हें ये बताना पड़ेगा कि ये जो कैपेसिटर है, इसके लिए चार्ज की वैल्यू प्लस क्यू होगी. अब जरा देखा जाए कि इनके बीच प्लेट सेपरेशन डी है. दोनों प्लेट में से प्रत्येक प्लेट की जो एरिया है, क्रॉस सेक्शनल एरिया है, वह ए है. अब हम करते क्या है कि मान लेते हैं कि इन दोनों प्लेट के बीच की जो पोटेंशियल डिफरेंस है, पीडी बिटवीन टू प्लेट्स, इट इज भी वोल्ट मान लिया जाता है. इन दोनों प्लेट्स के बीच की जो पोटेंशियल डिफरेंस है, वह भी वोल्ट के बराबर है. और दोनों प्लेट के बीच जो इंटरवेनिंग मीडियम है वह एयर है। अब ऐसा करते हैं कि इलेक्ट्रिक फील्ड इंटेंसिटी, इसके लिए भी हम मान लेते हैं लेट द इलेक्ट्रिक फील्ड इंटेंसिटी एट एनी पॉइंट लाइंग इन बिटवीन द रीजन ऑफ द टू प्लेट्स, let it is equal to capital E. So it is clear that the value of electric field intensity E, it will be equal to sigma divided by epsilon naught. Now you know that electric field intensity, it is equal to negative potential gradient. So mind here, the potential difference between these two plates, it is V, so we'll write V divided by the distance between two plates, this is D, so we can write E is equal to minus V by D. This is the negative potential gradient, and this negative potential gradient is equal to capital E. So let us take this is equation number 1 and this is equation number 2. See here, from equation 1 and 2 we can write from 1 and 2, from equations 1 and 2, what do you get? You get V by D, it is equal to sigma divided by epsilon naught, and from this very relation you can find the value of V. What is the value of V? V will be equal to sigma into D divided by epsilon naught. Now I am interested to find the value of capacity of this parallel plate capacitor. Let the capacity of this capacitor, it is C. So C is equal to what? Charge divided by potential difference. The charge of this parallel plate capacitor, it is Q, and the potential difference is V. So we write C equals to Q by V. So right here we can write Q divided by V, and the value of V, it is sigma into D divided by epsilon naught. So we can write this very relation as epsilon naught into Q divided by sigma into D. You know very well, sigma, it is equal to charge per unit area. The charge is Q and area is A. So we can write sigma is equal to Q by A. So let us put the value of sigma equals to Q by A in this very relation. What do you get? You will get epsilon naught into Q divided by Q divided by A into D. Remember here, Q will be cancelled out, and this A, you will get epsilon naught into A divided by D. So the formula for capacity of a parallel plate capacitor, it is C equals to epsilon naught into capital A divided by D. This is the formula for capacity of a parallel plate capacitor. From this very formula we come across the general conclusion that the capacity of a parallel plate capacitor is directly proportional to the cross-sectional area of the plate, and it is inversely proportional to the plate separation D. Larger the value of area A, larger will be the value of capacity, and smaller the value of area, smaller will be the value of capacity. Similarly, smaller the value of D, larger will be value of C, and larger the value of D, smaller will be the value of capacity C. And at the end of this video channel, I am going to tell you, you must like this video, share it, and try to subscribe. Okay, thanks.